Hi, my name is Kiran Baburaj and today we are diving into binary search tree deletion. In this video, we will explore how to delete nodes from the BST. We will cover three key cases: deleting a leaf node, deleting a node with one child, and deleting a node with two children. Now let's visualize the deletion process. First, we will delete the leaf node, node 20. We start at the root 50. Since 20 is less than 50, we move to the left child 30. Then, since 20 is less than 30, we move to the left child again and reach the node 20. Since 20 has no children, we simply remove it from the tree. The parent's left pointers is updated to none. Next, let's delete node 30, which has one child, node 40. We start at the root 50. Since 30 is less than 50, we move to the left child 30. Since 30 has one child, we replace it with the child 40. The parent's left pointer is updated to point to 40. Finally, let's delete the node 50, which is the root and has two children, 30 and 70. We start at the root 50. Since this is the node we want to delete, we find its in-order successor, the smallest node in the right subtree. We move to the right child 70, then its left child 60. This is the successor. We copy the successor's key to the root node, then delete the original successor node 60 from the right subtree. Thus, the node is deleted and BST properties are maintained. Now let's look at the code for deleting a node from a BST. The delete method is recursive and handles all three cases we discussed. The method takes key as an input and searches for the node to delete. If the key is smaller than current node's key, we move to the left subtree. If a left child exists, we recursively call delete on the left subtree. If the key is larger, we move to the right subtree. Similarly, if a right child exists, we recursively call delete on the right subtree. If we have found the node to delete, we handle three cases: no children, one child, or two children. If the node has no left child, we return the right child. If the node has no right child, we return the left child. For nodes with two children, we find the in-order successor, the smallest node in the right subtree, and we traverse to the leftmost node in the right subtree to find the successor. We copy the successor's key to the current node, and finally we delete the successor's node from the right subtree. Thus, the method returns the modified tree. So let's recap what we have learned. Deleting a leaf node is straightforward, just removing it. Deleting a node with one child involves replacing it with its child. And deleting a node with two children requires finding the in-order successor and reconstructing the tree. The time complexity is in order of h, where h is the height of the tree. I hope you enjoyed the video. Don't forget to like and subscribe for more videos on DSA. Happy coding. Thank you.